Greetings, I am Daniel Peiris and my student ID number is 20220529. My Westminster ID is W1998850 and my research topic is harvest-wise machine learning driven market demand forecasting and price prediction for optimizing crop harvest cycles in Sri Lanka's agriculture sector. So this project is supervised by Mrs. Vinodani Tilakaratne. Agriculture is the backbone of Sri Lanka, feeding millions and supporting over a quarter of population through the employment. However, despite this importance, farmers face constant struggles. Their profits are shrinking, crop waste is rising, and their income is unpredictable. All due to the influences and the outdated systems that fail to meet today's agriculture need. Although agriculture contributes around 7% to Sri Lanka's GDP, farmers continue to battle with their overproduction, spoilage, and shortage. Market prices. During peak seasons, vegetables like tomatoes and cucumbers often flood the markets, resulting in unsold, spoiled produce. On other hand, price volatility in crops like chili and long beans cause uncertainty, making it difficult for farmers to decide what to plant and when. Adding to this burden issues like soil degradation or roots of and unpredictable weather. The core problem lies in the fact that most farmers still rely on outdated forecasting tools. These systems don't feel like reflect real-time changes in weather, soil health, or market demand because of this farmers often make poorly informed decisions. Planting the wrong crop at the wrong time or missing out high profit and other opportunities. A tomato grower might overplant only suffer from a price crash, while other misses the peak price period for chili due to a lack of timely insights. To tackle these issues, this research introduced a smart integrated forecasting system powered by machine learning and provide farmers with accurate and timely insights, helping them making informed decisions on what to plant and when to harvest and where to sell. The system is designed to simplify the complex data and present it in a way that useful and actionable for every farm. The system collects and processes real-time data from multiple sources. It pulls in live market price trends, weather conditions, and soil health data using information. It predicts future demand and price for each crop. The tool also includes a harvest calculator that estimates yield based on the farmer's location and land type and area under cultivation. The combination ensures the advice given is not only accurate but also tailored to each user's context. This initiative isn't just about technology, it's about empowering the people behind the fields. The goal is to give farmers the tools they need to improve their livelihoods, reduce unnecessary waste, and make smarter decisions that lead to more stable and sustainable agricultural practices. Current systems fall short in several ways. They rely on outdated static data, can't quickly adapt to sudden changes like floods or price hikes, and don't account for sustainability and farming. Most importantly, they are not designed with rural farmers in mind, making them hard to access or understand for the people who need them most. This research delivers values in three areas. In the research domain, it brings together real-time data and advanced machine learning models, including neural networks and regression trees. In the problem domain, it translates the complex predictions into a clear, user-friendly advice and that helps reduce the waste and boost income. For society, it promotes sustainable agriculture, supports government planning, and contributes to building long-term resilience in the farming community. There are still challenges to overcome. Data from remote rural areas from incomplete or unreliable. The user interface must be simple and intuitive, ensuring farmers with little digital experience can still benefit. Finally, the system must be scalable. It should be handle different crops, regions, and user needs without sacrificing accuracy or usability. Let's move on to the backend part. This backend script is the core engine behind a smart agriculture forecasting platform built using Flask and designed to work seamlessly with front-end interface like React and TypeScript. It provides real-time predictions and insight for farmers and agriculture stakeholders. Once the application is started, it first loads pre-trained machine learning models, one set for crop pricing forecasting and another for demand forecasting and bundled in the pickle. The API offers several key endpoints. Yield prediction part. This takes basic user inputs like crop type, location, and land size to estimate the potential harvest in kilograms using simulation formula. Price prediction. Given a crop and a date, the backend uses machine learning to forecast the future market price based on historical trends and seasonal features. And the demand prediction. This leverage max time series models to estimate the expected market demand for a specific crop in upcoming months. Chart data generation. This endpoint combines both price and demand forecasting to provide data for interactive charts. It generates a 6-month forecast, offering users visual outlook of upcoming market conditions. And last, profitability calculator. Another endpoint allows users to estimate their potential revenue, costs, and the profit margin based on input like expected harvest size, market prices, and operational expenses. It also calculates ROI and profit margin percentage to help in decision making. Finally, the server configured to allow cross-origin requests so that front-end applications like on running local host can seamlessly communicate with the backend. In essence, this backend turns agriculture data into smart, actionable insights, helping users plan better, predict smarter, and grow profitability. Now, let's see the machine learning model uh, for the harvest calculation. In this part of the project, using for calculate the harvest, it uses data set of agricultural information from Sri Lanka to make predictions based on user input. The scripts start by loading the dataset and setting up interactive widgets like drop down and input fields. These widgets allows the user to select a crop type, province, district, landscape, and specify the land size they plan to cultivate. Uh, the drop-down menus are dynamically, for example, when user select a province, the list of districts automatically updates to the show only the ones relevant to that province. A pre-trained machine learning model which was previously saved in and then loaded. When the user clicks the predict hours button, the system takes all the selected inputs and passes them to the model. The model processes this data and outputs a harvest prediction, estimating how many kilograms of the selected crops the user can expect based on the conditions they provided.